Alright, so now we're going to be solving example 3.2 of the book of Fundamentals of Electric Circuit by Charles Alexander. So this is also a question of nodal analysis, and we have been asked to find out the node voltage V1, V2 and V3. So this is the node V1, this is node V2, this is node V3. So again, the very first step that we are going to do is determine the direction of current flowing in the circuit. So in node V1, the current is flowing this way, and then this way, this way, and then current is going this way, and then current here is going downwards, and it is going downwards here as well to the ground node. So the very first step that we had to do is determine the direction of current, and we have just done that. Okay, so now we're going to be applying Kirchhoff's current law, which is KCL, on each respective node. Kirchhoff's current law states that current entering a junction is equals to current leaving the junction. So in the node V1, the current which is entering, let us first write KCL applied to node V1. Okay, the current which is entering is 3 amperes, and the current which is leaving is V1 minus V3 by 4 plus V1 minus V2 by 2. Okay, now we're gonna take LCM. This would be V1 minus V3 plus 2V1 minus 2V2. This would be 12. This would be 1 plus 2 is 3V1 minus 2V2 and minus V3. So the final result of this equation is 3V1 minus 2V2 minus V3 is equals to 12. Okay, this is equation number 1. Equation 1. Alright. Now we can apply KCL on node V2. Okay, let us write KCL applied to node V2. Okay, the current which is entering node V2 is this. The current which is leaving is this, and the current which is leaving is this as well for the node V2. So the current entering is V1 minus V2 by 2, and the current which is leaving is V2 by 4, and then V2 minus V3 by 8. Hope that's clear as well. Okay, now let us simplify this as well. V1 minus V2 by 2, taking LCM, this would be 2V2 plus V2 minus V3. 2 1s are 2, 2 4s are 8. This would be 4V1 minus 4V2 is equals to 3V2 minus V3. Alright, the final result would be 4V1 minus 7V2 minus 7V2 plus V3 is equals to 0. I hope I haven't made any mistake in the basic arithmetic. Okay, this is equation number 2. Alright, now we have to apply KCL on the node V3. I'm just going to separate this. Okay. Alright, now applying KCL on node V3. So the currents which are entering in node V3 is this current and this current, and the current which is leaving is this one. Okay, so the current entering would be KCL on node V3, V2 minus V3 by 8 is entering, plus V1 minus V3 by 4 is also entering, and the current which is leaving is 2Ix. Now we can see that in this equation that we just wrote, there are four variables: v1, v3, v2, as well as ix. But like we have three equations, so we cannot solve an equation involving four variables, right? So we need to substitute ix with the node voltage v. So we need to basically write ix in terms of v. So as we can see in the circuit diagram, that they have told us that this current ix is basically this current, right? It is this arrow is basically the current and it has been denoted by ix. So we're going to be writing the expression for ix. Ix is let's see right here. Ix is what? v1 minus v2, v1 minus v2 by 2, right? We can see this, that this is node v1, this is node v2. So the current according to Ohm's law is equals to v is equals to IR, right? So we get current using v upon R. So the difference between the two nodes v1 minus v2, v1 minus v2, this would be the difference in voltage between these two nodes, and then divided by resistance, it would give us current. Hope that's clear. So let us rewrite this equation. Now we're going to be replacing the expression of ix with voltage v1 minus v2 by 2. 2 cancels out, taking LCM here. 8, this would be v2 minus v3 plus 2v1 minus 2v3 is equals to v1 minus v2. Now let us simplify. So this would become 2v1 plus v2 minus 3v3 is equals to 8v1 minus 8v2, right? And now let us simplify more. So this would become 6v1 and this would be 9v2 and this would be 3v3 is equals to 0. This is the final result of equation v3. Okay, now since we have three equations, involving three variables, we can solve these equations simultaneously. I'm just going to plug in these three equations in the calculator. Okay, 3 minus 2 minus 1, 12. 4 minus 7, 1, 0. 6 minus 9, 3, 0. Okay, now we have got the answers for the node voltages. V1 is 4.8 volts. V2 is 2.4 volts. V3 is minus 2.4 volts. So I hope this question was clear to you guys, and I will meet you guys in the next video. Thank you for watching.